Okay. So is it Yair? Is that, am I pronouncing
Yeah,
that right?
yeah, Yair. There's no really good. It's hard to pronounce.
Yair. Okay.
Yeah.
Well, thanks for joining me. I saw the article in the Hub about the work that you and your colleagues are doing in Israel and dealing with automated production of enabled devices, and it sounded fascinating. So I just wanted to hear more about what you're doing and be able to share this with the rest of the community. So maybe you could just tell me a little bit about the work that's going on out there.
Yeah, sure. So I think it was maybe 6 or 7 or 8 years ago. Haifa 3D actually started as an organization in Israel to promote the field of 3D printing, not necessarily related to e-NABLE. But then at some point, a physician unrelated to orthopedic or anything just heard about e-NABLE and approached Yoav and Yaakov, who founded the organization, and it said, "This is great. Let's do it." So they
Nice.
started as yeah. So they started as to produce these enabled devices. I think it was the Raptor Reloaded at the time. And actually, I started working with them as an undergraduate student at the Technion. I did my bachelor's project under Yoav's supervision. We actually worked on adding sensing. So we added the sensors to the hand. I think this project was published. It was at the time it was the Google Plus group.
It did get imported into the Hub, so I saw it there just the other day.
Oh, okay.
Actually. So you added a sense of touch, ability to sense heat and things like that, right?
Yeah. So that was the project back at the time, but we actually found that that's not as important right now. But mostly we are dealing with the problem of fitting these devices. Now, because Haifa 3D is very close to the Technion, we have volunteers that are engineers, which I think it's not all chapters have this. So we have volunteers that can do 3D design and modify, for wider hands or stuff like that. As you know, when we scale the hands, we can do a linear scale in all dimensions. Once we want to do something more complicated, the hinges, stop working, and so we actually found that this is the main problem, and we had a project for body powered hands. So we have a model that's very similar to the Raptor Reloaded because we started back in the day. We actually are now working on modifying it to make it more similar to the Phoenix. And the idea was to make it is easily customizable. We want to be able to change the width of the palm separately, the length of the fingers, the length of the palm, make everything as customizable as possible, because we saw that we have the common cases, but actually they're not, from what we found,
common.
They're not that common. Yeah, we have so many cases that just don't fit. You can fit a regular hand to them, but it's going to be very, very big, maybe, or something like that.
So before we get into the details about how you're doing this and how you're addressing the challenge, tell me a little bit more about the Haifa 3D organization today. What has it grown into? Who is it made up of? Just help me to understand the organization a little bit.
So as I said, Yoav Medan and Yaakov Malinovich started it. Yoav, I think, is relatively active at the Hub. Right. They started as to promote the field of 3D printing, but now we're actually mostly doing the hands, and we actually also have a very big project that kind of started because of the hands, but it's not really 3D printing. So this is mainly what we do. I can talk about it a bit more soon. Okay. I think if you think that's interesting. So actually this is mainly what we do. We do the hands, and we do it's called the Ekfafitz. It's sort of a glove that helps users to open their hand. So spastic users, or I'm actually not as involved in that project. I'm mostly dealing with the hand stuff, so I might not be as accurate.
Sure.
Patients or users with spastic hands, that they can only close them. They can't really open them. So there is some sort of a neurological disorder. It could be caused by trauma or a stroke. So it's a simple glove that has springs in it that open the hand, and then they can counteract these springs, so they don't have a problem applying additional force against these springs when they close the hand, but they can't really open it. So it really, yeah. So
is that a design that your team has shared? Is that an open source design?
It's definitely open source. I don't think it was shared. This is actually something that we're trying to promote, to make it do the regulatory requirements to actually be fitted by physical therapists and occupational therapists. So this is. But it's open. It's open. We're not gonna patent or anything. So
yeah, I only ask because I'd love to get it added into our device catalog, even if it's not a 3D printed device. It's still something that we could list there as an option for our volunteers.
Yeah. So the only thing is that it requires some knowledge in textiles and
I see.
and sewing, but this is actually something that we got funding from a few national bodies in Israel. So the idea is to make it very simple and to have it mass produced. It doesn't need to be as customizable as the hands. So I don't know, maybe hopefully at some point someone could order this glove from us, and fitting the actual doing the fitting process, it's not going to be as complicated. But this is something that maybe we need to talk with Yoav about, because he's definitely the leader of the project, and he'll be.
Sounds good. Yeah, no, it just seemed like something that we have so many volunteers with different skills. Not all of them are into 3D printing. Maybe someone would like to do something that involves sewing. But I'd love to go back to talk about the customization side of things. So you talked about being able to customize devices, but do it in a way where we're not messing up the screw holes and the hinges and things like that. So how are you going about achieving that?
Yeah, so as I said, we started with the body power designs, but then at some point, because me and Shunit, Shunit is also a volunteer, and she's also studying at the Technion. We're both studying in a robotics lab. We started actually working on the motorized design. So the body powered is kind of on hold, even though I think it's going to be easier to make it usable by volunteers. But anyway, the way we approach these design modifications, this customization, is a design in SolidWorks. It's a CAD software. So the idea is to pick certain dimensions that are going to be important, and then we link it across the different parts of the hand. So currently, let's say the body power design that we have is currently, we can change everything. We can change whatever we want, but it will take some time. So if I want to change the length of the fingers, I'm going to need to go into each part, change the length, go to the palm, change the dimensions there, and then make sure everything, gets rebuilt fine.
So you're doing parametric modeling.
Yeah. So this is going to be parametric modeling. And also, by the way, we saw that we spent some time because these hands are, even if they're changing in size, they're basically the same. They have the same parts and the same everything. So we saw that even the time we spend on organizing these parts in how to print them in orientation. So the orientation is significant for strength, right? And for supports. So just orienting all the parts the way we want them and organizing them on the print platform, even that takes us time.
Sure.
And yeah, so so the idea is to have, we have all these parts, they are linked together. As you said, there's a parametric design. We can change the dimensions we want. Everything changes at the same time. And then we have assemblies. So we have assemblies that are functional. So the hand looks like a hand, right? Okay. So this is the usual, how usually an assembly in a CAD software would look. You have an assembly of the device to see how it, how it looks.
Right.
But we also have an assembly to print. So this assembly, you can choose the print bed size, and then in our case, we mostly use up mini printers, so very, very small printers. So in our case, it's 120 millimeters by 120 millimeters, and everything gets laid out on this platform, right. One or two platforms, depending on the size of the hand and depending on the size of the printer. But everything gets laid out in the right orientation. And, it's just, take this assembly, save it as STL, and put it in the printer.
Yeah, that's very smart. And as you describe this, what I'm thinking about is, I don't know if it's maybe because you guys are linked in with people that are engineers and professionals. Maybe you have access to SolidWorks in ways that others don't. A lot of us, don't have access to that, and we've started to lean towards using Autodesk Fusion 360 because we can get it free of charge, but it has similar features. And I'll bet we could do, I know we can do the parametric modeling in Fusion, and I suspect we could do the same thing that you're describing with the assemblies. I just never thought about doing it that way. That's really, really smart idea. And so you are using SolidWorks then to actually, are you just exporting that assembly as an STL, or are you using SolidWorks to actually generate G code?
No, there is a possibility to do it with specific printers, but we usually save it as STL and yeah.
Bring it to your slicer. Okay, that's very smart. Okay, so then you're using the CAD software. So then anybody that wants to build a custom hand, the customization is actually happening in SolidWorks. You're using that to adjust parameters and generate the modified files. Okay. So then does everybody on your team have access to, do you have licensing set up in a way that your whole team has access to that?
Yeah, because most of us are at the Technion, so the Technion has a licensing for that, so it's not really an issue. Okay. But I agree, Fusion is way more accessible in that sense.
Yeah, but it's a great idea. Now, I'm also always interested in can we build on your work, so we don't have to start from scratch. And I've always had problems in the past trying to, bring things from SolidWorks to Fusion. You can get the geometry, no problem, but trying to export with all the sketch layers and with everything tied together, I've never found a good way of doing that. Are you aware of any good options for that?
There isn't a good way of doing that. I know SolidWorks has a tool for, it's called FeatureWorks. So it's trying to understand what features were used in the design of the part. So you will import the geometry, and then it tries to understand what the features are. Maybe you have some extrudes, some fillets,
that's like for bringing objects into SolidWorks.
Yeah, and also it's not working very well. I mean, if you take something like I don't know, maybe if we think about the Phoenix, so you take some of the pins. I assume that actually, even for that, I'm not sure, but maybe for the pins, it's going to work. But if you take something like the fingers or the palm, definitely, there's no way that it's going to be able to rebuild that in features. That's very, very, very hard. It's so this is not something that it's not going to work. Well, the idea for this specific design is that we kind of thought in the paper we wrote. So we have the scanner and this setup with the camera to capture the user's dimensions. So the idea is that this could be done remotely. So if we have the license, you pass us all the dimensions, everything gets generated, and then you get back the files. So the idea is that once we finish working with, once the design is made up, nobody else needs to open SolidWorks. Only, we need to have one place where the files are being generated.
The SPL files, and then the volunteer can take it. Yeah, that's a good point. Now, did you say you use? Whoop. Hold on, sorry.
No worries.
Did my microphone just change? I'm not sure what just happened. Okay. So did you say you use sizing photos? Do you ever use like 3D scans or 3D geometry of the limb, or do you just stick with sizing photos?
So again, it really depends the activity that is now going on at Haifa 3D. What we actually, when we meet mostly children, but also adults, this is one thing. These models that I'm talking about are not fully functional. We're not giving them away yet.
Okay.
So this is done in the usual methods that all the community is using. We started using this was actually published in the hub a while back, the scanner with the 3 cameras by Guy Medan or Guy, I think Guy published it in the hub, and it's available for everyone. The only thing is that we use an old version of the RealSense cameras, so this might need some work. This is just what we had, but they're not for sale anymore. So anyway, but now we have this low-cost 3D scanner that works well. So actually, we had a user that has a working thumb, but it doesn't have much flexion at the wrist. So we created, and I tend to share it. We had a lot of success with the model. This model. It's not just we use it. It's not the first time we used it. We create a model that is body part. It's based on the Phoenix, but it's operated by the elbow. But it sits only on the wrist. So it's connected to the elbow with like a Bowden cable, sort of like what you see on bicycle on the brakes. So you have a metal wire through a tube, and then you still get this rotation of the wrist. So basically, it's elbow powered, but you still have this movement. But it's it's for users that don't have the ability to move the wrist. And we had like I don't know, trying to think, maybe it's the 4th one that's using this model, and actually it's working pretty well. But I started talking about it because he had a thumb, and in these cases, we saw that it really helps to have a 3D representation of the hand to make sure it fits into the palm. It doesn't necessarily have to be a thumb. Any residual finger makes the change. It's not just a matter of scaling. You need to cut the STL file and change it. So so this is what we did for Dudu, and actually you can see I think Yaakov uploaded a video of Dudu with the hand to the Facebook page of Haifa 3D. But in any case, because we needed to cut the device, and what we did usually is we take the residual limb, we put it on a piece of paper, we trace the hand, the shape, and then we just extrude it in a certain shape. So this gives you kind of a 3D representation of the residual limb. It's not very accurate. So for Dudu, we used actually the 3D scanner setup that, as I said, was published. And in this case, we took the scan and actually could make sure that the way we cut the Phoenix hand around the residual fingers actually works. So this was actually one of the first time we actually gave a device that is really based on a scan, and it really worked. It worked really, really well. I mean, the fitting was spot on. So it was very, very nice. But very exciting. But usually we use just pictures and measurements if we do elbow powered hands. So it's either the Quawo hand or the unlimited arm or something like that. So we use, we simply measure that by tape. This is, it's kind of separate the R&D work and the actual device fitting. They're kind of separate. They're not different devices, different procedures.
So if you don't mind, I'd like to see if I understand things correctly here and just kind of recap what I heard about this production process. So getting back to not the design side of things, but just producing custom devices. It sounds like the sizing methods that you're using are pretty typical for what the community is doing. You would get the same kind of sizing photos, but you bring this into SolidWorks, and you have the models in there developed using parameters, so you can specify a variable for the hole diameter or the tolerance amount and things like that. You can adjust those parameters at any point, right?
Mm-hmm.
And then so you can make these parametric adjustments to modify these models as needed, while maintaining the circularity of holes and all that good stuff. And then you can lay those out automatically for a print bed by using assemblies that are designed for a specific build area, and export that to STL, and you print those out. Do I have the gist of it correct?
Yes, that's the concept. The other thing that I think is kind of, or can call it special about this design, is that this is something we talk about in the paper. We tried to create a concept that is based on, we called it a skeleton and a skin. So we tried to make it, the idea is it's kind of bio-inspired.
Okay.
So we have the joints and everything that actually, create the structure, the kinematic structure of the hand. So all the joints and everything. So these are, very simple links that are connecting in the pins. So this is everything there is called the skeleton. And then, we wrap it up with something that we call a skin. So the skin can be, different things, as we see in the community, and we see it a lot of time in Israel. The kids that we see usually want a very colorful hand. They love the Phoenix design in most cases. So the first skin that we created is an Ironman skin that we simply found an STL online, and we put it on top of the skeleton. So and also, mostly when we meet adults, but not necessarily. We, some cases they want something that is more human-like. So we have,
absolutely.
So we have again a skin that we found online. We didn't create it. We don't really have a lot of designers in the team, only engineers. So we took a skin that was created by someone else, and then we put the same. We take the same skeleton, but we put a different skin on it. And maybe the idea is to have more skins, more ideas that we didn't think about. But
so help me to understand this part. How do you put a skin on the skeleton? Is this taking a 3D model and actually incorporating it onto your skeletal models?
Yeah, so this is not something that's immediate. It's not like we're gonna publish the skeleton and somebody's gonna say I want this one and download it and it's gonna work. It requires some fitting, but and again, this is not fully working yet. But the idea is to make it as simple as possible to incorporate new skins.
Yeah. So it's sort of a modular approach where you'd be able to use different. That's great. And it's this would be a little bit out of scope for today's discussion, but I'd love to follow up with you separately, because I'd like to learn more about some of the design elements that you guys have chosen. We actually have a new team that's working together, and we're meeting weekly to develop a new design for the community that's kind of pulling from some of the best parts that we found from our different designs, and we're trying to make different improvements. And we're right now we're in the phase of just exploring different options for, like, what is the mechanism that we use for the the extension and of the fingers, and do you use strings, do you use elastics, do you use metal springs? There's all different kind of mechanisms you could look at using. How do you make it quiet, or what are the different kinds of approaches for different materials? Just there's a lot of considerations, and I'd love to hear what you guys have done, because it might give us some ideas about how to approach that stuff. So maybe we could have a separate discussion about getting into some of those design choices that you guys made.
Yeah, sure. Sounds good.
Yeah. So then what are the plans for this? It sounds like you're moving towards something. You're moving towards the ability to produce these more customizable devices in a more efficient manner. Is that so that you can just continue to do more of the e-NABLE type volunteer work and just kind of increase the scale of that? Or do you have other plans as far as where this is heading?
Actually, it's just, this is, for now, this is just a plan, is to expand our activity. So the idea is that, a volunteer doesn't have to sit so many hours actually customizing the device. It's going to be a few clicks away, and also the result is going to be better. When I started volunteering in e-NABLE, took me 2 or 3 tries before the hand actually fit well. Sometimes it's too big, sometimes it's pressing at specific points, so it hurts. And now it's much faster, and this is caused, I think, mainly because of experience, not just mine. We have other volunteers. We have physical therapists, for instance. They're also more experienced with these devices. So we're trying to make it simply easier, for volunteers to fit these devices and again get a better result. The result we got with the 3D scanner, and again, maybe it's not enough to do one case. Maybe it was just luck, but hopefully not. But it's definitely something that we need to try more and understand if it helps. But if because of the scan we got this excellent fit, first try, then this is what we want, right? It's so expand the e-NABLE activity in Haifa, reduce the time we spend, but also give the ability to volunteers that are not engineers or not have a lot of experience in design. They're going to be able to create these great devices that fit very well. So
and that's the key. You're doing something that I think is exactly the right direction that we want to be trying to head. This is something that we've struggled with for years, quite frankly, as a community. Just getting access to the solid body, original CAD files for a lot of our designs, we just haven't been able to. The community works with, as we work with STL files, we work with meshes, and there's very little you can do with that. You just can't work with a mesh in the way that you can. So we're really struggling with how do we go about getting solid body versions of our existing designs. And maybe the answer will end up being that we just focus on making sure that the new designs we're developing get done in a way that we have the solid bodies. But moving forward, I think you've got it right. We want to develop these parametrically, whether it's in Fusion or SolidWorks, develop them parametrically. And I love your idea of using the assemblies. I could see us setting up, for example, a template for Fusion 360, which any of our community members can get for free as an individual and a volunteer. We could set up templates that would include perhaps these different assemblies for the most common 3D printers or printer sizes, and have different templates for each of our different designs, assuming we can get them in that solid body form. So the vision here is really exciting. It's going to take us some time to get there because we don't have most of our designs in this format, but at least we can urge our members that, hey, if you're designing something new, don't just share the STL files. Make sure you make the CAD files available to the community because we can do a lot with that. So I actually have a license of SolidWorks. I don't use it much. I'm not very skilled with it. I wonder though if you might be able to share one of your files just so I can see how you set up some of these assemblies and see if I'm able to maybe duplicate that over on Fusion and figure out a way to do the same thing there.
Actually for the assemblies, for the the 3D printing assemblies, even if it's much harder to make it all the parts in one platform, but it's a lot easier to take, even like you get for the Phoenix, right? The Phoenix, you have, I don't know, maybe the tips, the phalanges, right? The palm, the gauntlet, and then all the other small parts. So it's not a lot of STL files. So it saves most of the work. In SolidWorks, usually when you export, and I think also for Fusion, I assume, if you make some changes and then you re-export the STLs, every different part is is saved individually. And also, if you do it from the assembly, it's being saved in the orientation. It's in the assembly. So maybe if your fingers in the assembly looks like that, they're a bit flexed. That's the way they're going to be saved, and that's a nightmare for 3D printers. You have to take every individual part, and that's like
they have to be laying flat. So
like
we oriented all of our models that way. Just like if you look at our CAD file for the Phoenix hand that we have in Fusion, they're all lying the way they would be printed. We have them all oriented with the flat side down and all that. But that's all you get. Then you have to export them, individually or what have you. So I like the ability to group them and export those grouped STLs. So I'll look into that further. You've given me some really good ideas. But ultimately, it's, I think the key point is getting our designs into a solid body format. I think it's relatively, once you have it as a proper, as a CAD file, including, your history, it's not hard to go back and kind of reinsert the parametric elements, but we've got to have the solid bodies first. So,
I agree. But also, if you making this parametric and also let's call it smart parametric designs, because you don't just want to have it's going to be there, right? You have the ability to change every single dimension there, but some of the dimensions are simply not interesting. Maybe you do some kind of fillet so you don't have sharp edges, and the radius could be 10 millimeters or 11, but you don't really care,
right?
As long as it's working. But sometimes, if you change too much dimensions,
absolutely,
I don't know, the fillet is not going to work. This edge is going to disappear. So so these designs need to be parametric, but they are also, they need to be customizable in a way that if you change them, and again, because it's, when you do this simple scaling of STLs, they work great, right? You just bump everything by a certain number and that's it. But
you're right. Once you start doing the individual manipulations, things start happening. It's a great point. So you really have to think about it during the design process each step of the way. And for a certain component, you might not use a parameter to specify, but you might use an equation that's some multiple of a parameter or something like that. So you're right.
So it's definitely something to think about. Creating this, this requires a lot of careful work, and then after you finish, you need to play with the numbers and see that
that's right. See if it holds
rebuilding. Because when you scale an STL, it's going to work every time. But when you change the dimension in a parametric model, it's in some cases it's going to simply break. Let's call it. SolidWorks sometimes have errors. It's not able to rebuild, or again, some dimension might be bigger and a specific edge disappears, and then once it's not there, the software. So we had some, we learned a few things, like fillets are usually problematic. It's a kind of vulnerable feature because it's related to edges. It's not like when you have a sketch and you extrude it, the sketch is there. It's not something that's going to disappear. But if you do fillets, for example, you might lose an edge. So it's a problematic feature, for example. You have, anyway, without getting into details, it's not just creating the parametric designs, but it's also thinking about how to create them. And sometimes even after you finish the design, you need to go back and rebuild it, create the same part again, but in a different way.
So now you mentioned before that you were originally working with the Raptor Reloaded and you've been modifying it and kind of bringing it in the direction of the Phoenix. Then you talked about this hand that has the sort of skeletal and skin components. Is that the same hand that we're talking about?
The skin and the skeleton is for the motorized version, the one we talk about in the paper. But ideally, I mean, once we have it working properly for the motorized version, we hope this was the intention, that it's going to be relatively easy to make it suitable for body powered device, because you basically take the palm and then you take all the motors out, and there should be enough room for the residual limb. Maybe make some changes there, and then you have the Gauntlet, and the Gauntlet is relatively easy to design because it's usually the flat version with the thermoform. We really like it. It's just working well, right? We love it. It's an easy print, it's an easy design, and it's very, very strong, and it's simply working.
Yep, good. Well, it's exciting work. I'm glad I learned more about what you're doing, because it helps with what I'm working on, and some others are working on it. You've given me some great ideas. I really look forward to seeing. I know you're still working on some of these designs, but both the powered and the body powered versions, I'd love to get these into our e-NABLE device catalog when they're ready. So please keep that in mind. once you're at a point that you feel comfortable sharing them, let's get them up there onto the hub, and including the powered one. We have so many, for example, classrooms, students groups that are involved in e-NABLE, and those powered designs would give them some great learning opportunities, because it gets into the electronics and wiring and all kinds of interesting stuff. Maybe a Raspberry Pi, I don't know what's going in there, but it gets into a lot of interesting areas. So it would be great to have some of those in our catalog as well.
Actually, for that, we had a project that started way back. We have a super talented engineer, is maybe 85, 86 now. So he created
more powerful than a retired engineer.
Yeah, it's so much experience, and he really created an amazing design, and he worked on it with Shonit. She did her bachelor project on this design, and they actually, we have a design there that is working really, really well. And then this is published in the GitHub of Haifa 3D. This is just very recently, so this is why maybe she didn't publish it in the hub, but it's there. And this design is working really, really well, but it's using gears, so it's not really customizable. It's sort of a one size, but for the it fits adults pretty well. Again, we haven't experimented with users, but as a design, it's fully open for everyone. The mechanical design works well, and also the electronic design. There is, we try to make it as accessible as possible. Also for the other model that I talked about it before. But the idea is that we have a printed board, and these days printing a board, you just order it online. It's $5 for it. It's a very simple board. It's just 2 layers, and all the soldering is through holes. So there's no complicated soldering, and it's sort of we call it Legos, because we just take these breakup boards from Polulu and different companies, and we take the ESP, and everything gets mounted on this board that Shonit created. So easy soldering, very cheap production, and pretty much accessible to everyone. And because we use ESP, so it has Bluetooth, and there's actually an Android app that you can download and control this hand. And this is working. So this is something that's already available on the GitHub, and I think for students, it's a great platform.
Sounds wonderful. I would really like to work on getting some of these into the e-NABLE hub if we can, because we have a device catalog there, and I'd like to have them represented there. We can just, we can link to your GitHub page for the files or what have you, but if we can get the information into the hub, it'll make it much more accessible and easier to find, because you guys are doing so much great innovation out there. I didn't know some of this, and I'd like to make it more visible to the community. And these days, the e-NABLE hub is the place to do that. So I can help you to get it in there. If you can share the details with me, and I actually have a form set up where you can just kind of fill out the details for design and share the links and all that, and that'll send me everything I need to build out a page in the device catalog, so I can share that with you.
Okay, that sounds great. I think I think Shonit finished uploading everything, but I'm not entirely sure. But I think it's there, and we'll be happy to see people anywhere using it. That's why it's
exciting. Yeah, we don't have enough of those kind of powered devices. Those would be a lot of fun, especially like you said, for a classroom project. That would be great.
Yeah, well, we kind of trying to implement the insights from this. This model, it doesn't have a lot of the features that we want. The customizability, the skin, it looks well, but it's it has just the one look, and that's it. So we want the ability to change the appearance. We want the ability to change the size. We want the ability to it's not what we want, but it's definitely a step in the process, and we try to incorporate the things we learned from that in our design. But for instance, the gears, they're 3D printed. It's not really a problem, but once you start changing the dimensions, it's not working well. Tolerances, and you start to have problems.
So knowing what you're trying to do here, it seems like you've developed a pretty good sense of what your goals are. And that the design that you have isn't quite there yet. You're working on it. Do you see a point in the future where you might start like, okay, time to start from scratch and basically just build, a new design to build in these sort of concepts and capabilities sort of with fresh models and all that? Is that a path you might go down?
So the skin and the skeleton concept is started, it's pretty much started from scratch. We took ideas from the model Shanit made, which by the way also started from scratch.
I see. Okay, so you're already doing this. Okay.
Yeah. So the skin and skeleton, this is why it's not ready. We're trying to, I think the concept that's published in the article that was published in the hub, this is everything we want. Everything is customizable. Everything is, one click away. This was the idea there, because we see, all of us, we're volunteers, right? We don't have a lot of time to spend on customizing this device, and
right.
It can take hours and hours, right? Every time you customize, so it's a problem. So when the printer is working, if the design is made well for printing, right? Usually you have a good printer and you have a good design. When the printer is working, you don't need to do anything, right? It's the printer is working, not you.
Right. That's right.
So this is what we want, and this is why it's not working yet. We didn't really compromise on anything.
Well, that's great.
Yeah. So the design that's currently in GitHub has more compromises, but it works really, really well for what it is. So,
I see. Okay.
I think this is a great option for.
It really sounds excellent. So I definitely would like to, share. We'll share this video in the hub, but let's share those files and let's get this added into the device catalog, even if it's still a work in progress. It's perfectly okay. Yeah. Let's just get it out there, and you can start getting input from others, maybe, and people can start testing it and give you feedback. But I, just kind of thinking as a sort of just in a very visionary future, far off kind of a way for a moment. The latest model iPhones, for example, have like a basic LiDAR capability built into them, and you can do some 3D scanning with the phones now, and that's going to continue to improve. Do you see a day where we'd be able to take a smartphone and 3D scan a limb and use an app on the phone to analyze that scan and automatically generate the files for a custom hand? I mean, that's kind of the holy grail, right?
Yeah, definitely. No, we're not needing to build the scanner that we talked about. Yeah, that's definitely a great dream, and I mean the technology in our smartphone advances all the time, and
yeah, and I think the scanning is actually pretty close. The hard part is the software of analyzing that geometry and figuring out in an automated manner, how do you take a hand design and modify the parts to fit that geometry and then export custom STLs. If we could figure out how to automate that customizing process, that would be amazingly powerful. But I do feel like that's still a ways off.
Yeah, it will require some work, maybe some markers to to help understand where the wrist is, because every application is different. So we are actually starting to think that maybe for the 3D scan we'll mark the elbow joints and the different joints.
That's a very good idea.
Yeah, to actually place them properly in the design. Because for example, for the case that I talked about previously, I can see by eye where approximately this is an amputation by trauma, so you can relatively see where the wrist was. Because there is a thumb, you can understand what is what relatively and where to place it. But that we don't like things like, right?
That's right.
So definitely maybe incorporating some markers. It could be even if you're talking about smartphones and stuff like that. If you have also the RGB camera, it could even be stickers or something like that, or a dot with a marker. It doesn't have to be like a rigid body.
That's right. Yeah, that's a great. I never thought about the markers on a scan. That's a really good idea. You see that when you like there are apps where they'll like scanning your face to get you fit for glasses or things like that, and they'll all do the same thing. They'll have you mark the corner of your eye or mark a certain and things like that, and it helps them to locate those features. And I never thought about applying that here. That's a really good idea. To help identify the position of each finger joint, things like that. Very smart.
So yeah, I think that your concept is gonna definitely, it's feasible. It's just a matter of how many people we're gonna is gonna work on it. But I think the technology is it's possible.
Not too far off.
Yeah, it's just a matter of really working on that. It's kind of with face recognition, right? It's
That's right.
because it's a very important problem. A lot of people worked on it, and now you have the 3D scan of faces. They work a lot better than maybe 3D scanning, I don't know, a sphere or something that is simpler, just because these cameras know how to identify the different features in our face really, really well.
Right.
So it's just a matter of making this problem important enough for people to work on it, and then it's going to be resolved.
Yeah, yeah, that's a great point. Well, you guys are doing some very exciting work out there. I'll share this video on the hub so people can kind of see and hear more about what you're up to, and they'll hopefully share comments and ask questions there. And as soon as you have a chance, I'll get you that link for the form that I mentioned so we can get some of this work into our device catalog on the hub. I'd love to share it there. So
yeah, sounds good. I mean, yeah, the powered design that Shonit and Oded made, this is can definitely go there. I can also share the SolidWorks files for the the body power design, the parametric one, but it's not working well enough, so it's not ready. Yeah, but
no, it's entirely up to you. Whenever you're comfortable sharing things, that's up to you guys. But when you're ready, I'd love to get them out there. So
yeah,
thank you so much for talking to me today, though. This is really great to learn about. You've given me a lot of great ideas, things to think about. So thank you for that.
Yeah, I'm happy for that, and yeah, we'll be happy to be involved in whatever the community is working on.
Terrific. Well, keep up the great work, and say thanks to the rest of your team. Really appreciate you sharing this with us.
Thank you.
All right. See you soon.
Yeah, you too. Yeah. Bye-bye.